They should just have one big calculator with just the cube
Just have
button.
cube roots on it. That's it. All right, so find the side length of a cube. That's where cube roots would come in, right? If finding the side length of a square means I would square root its area, finding the side length of a cube means I would cube root its volume, because we're in cubic units, right? Volume. So I take 343, I cube root. Now, when you draw a cube root symbol, draw the square root symbol and put a 3 up in the top left corner of it. That's what a cube root symbol looks like. And what is the cube root of 343? Dawson? It is 7. So every side length on that cube is going to be 7 inches. 7 inches times 7 inches times 7 inches is how we get 343 cubic inches. By the way, we don't actually draw this when we draw a square root symbol, but a square root symbol technically has a 2 up there. The reason we don't draw the 2 is because that's pretty much implied. Okay. But you could cube root something, you could root something to the 4th power, you could root something to the 5th power.
Really,
Yep.
power doesn't matter. Could you like root something to the power of like 9 million?
You sure could if I could fit it in my calculator. You won't like the answer, but yes.
Let's try it.
All right. The cube root of a number is that, sorry, a cube root of a number is a number that when multiplied by itself and then multiplied by itself again, so 3 total times, equals that given number. Cubing and cube rooting are inverses. There's your cube root symbol. So on your calculator, if you were not really sure how to do that, if you have a calculator like the one I have, I'm not sure why I'm holding it up when I have a picture of it right here. So this is how you square root something, right? You hit that second function and hit that. The way you're going to cube root something is there's up above the exponent arrow right here. Up above that exponent arrow is a square root symbol that has an X in the top corner. And what did I say you need to do with that X? What does that X need to be? This guy needs to be a 3. So what I would do if I wanted to cube root 64, for example, which will give me 4, I would type 3, which would be right there. I cut my calculator off. I would type 3, and then I would hit second function, and then I would hit that button. And that's going to put the 3 up there where the X is. Then I would type in 64 and hit equals. So I'll do that again. I would hit 3, second function, and then my exponent arrow, which is going to take me to the cube root, not the cube root, but the rooting function with the cube root of 3, because I put 3 in, and then I would type in my answer and hit equals. If you have a calculator like this one, does anyone have this calculator, by the way?
I do.
Do you? No, you don't. You have the one I just had.
Oh,
This one actually comes with not only a cube button, but a cube root button. You can't see that, but it's a 3 right there. So it actually has a cube root button on it. It's kind of a nice calculator. And then, does anyone have a calculator like this one? Okay. This one. Okay. Now, you'll have to test this out, Julia, because I'm not 100%. I don't use this one anymore. I think that you need to hit 3, second function, and then this exponent button, and then type in 64 and see if it gives you 4. Okay, it's the other way around. Okay, thank you. So I knew that because, okay, yeah. This is why I don't like the calculators that you can't see what you're typing. It goes away as soon as you hit a button. So let's try this. 64, then the second function, then that button, and then 3. It gives you 4. Okay. Yes. Huh. Probably has the same thing where you have to hit 3, and then it probably has a button that looks like that right here. Probably has that. It might even have, some calculators have one. Some calculators have a button that looks like this, and then a button that looks like this for square roots and cube roots. Yes, Deacon. Yes. All right. So let's move on as we're, I'm assuming, I trust that you will come ask me if you're not sure how to do this, because how else are you going to do this homework? A perfect cube is a number that can be written as the cube of an integer. It's a similar definition to what we had for perfect squares yesterday. Squaring a number always results in what type of number? This is important that you know it, this. If you square a number, it will always be, I saw Jacoby's hand first. Positive. With the exception of squaring 0. Right?
0 would be 0.
Because square 0 would be 0. That's exactly right. Squaring a number always results in a positive, and that is why yesterday we said that you cannot put a negative inside the square root symbol. You can't square root negative 64. It doesn't exist. Yes, Brady. You can't see anything? Come ask me after class. I'll show you where you find yours. Okay. Oh, it's broke. It's broke. I'd invest in one of these. If you have to hold your calculator like this, you couldn't do the work. It's probably not super effective. It's time for new. It could be old. The batteries could be fading. The solar panels may not be working out. Whatever it is, I would probably just get a different one. Remember we said yesterday that this is not real. Go ahead and write not real there because you cannot take the square root of a negative number. Now, I can ask you for the negative version of a positive square root. Negative square root 64 is negative 8. That's fine. You just can't have it underneath the sign. What about cubing? When you cube a number, will it always be positive? Let's find out. What's 2 times 2 times 2? 8. What's negative 2 times negative 2 times negative 2? Negative 8. So you can cube a number and it could be negative. That means I can have negative symbols underneath my cube root signs. It's not underneath my square root signs. And that's because we know that when we have 3 negatives, that's an odd number of them. They won't all pair up. These 2 will make a positive and 1 won't. So it's going to be negative 8. Speaking of the cube root of 8, that would be what? 2. Yeah. What about the cube root of negative 125, Julia? Nope. The cube root of negative 125. Lucy? Negative 5. I think you were forgetting the negative sign. Remember, it's possible you can have a negative cube root, right? It's okay to have a negative sign underneath the cube root symbol. Negative 5 times negative 5 times negative 5 would give me negative 125. The same way I square root fractions is how I cube root fractions. Cube root the 1. Cube root the 64. What's the cube root of 1? 1. What's the cube root of 64? Now this one's going to be negative, and it's possible to have that negative. Cube root of 20, whoops, cube root of 27. 3. Cube root of 1,000. Maddox? 10. 10 times 10 times 10 is 1,000. And can I cube root 192 over 3? I don't think either one of those are perfect cubes. So what if I did my little trick? Saw that 1 plus 9 plus 2 is 12, and I knew 3 goes in. Sky, what does that actually reduce to? 64. And then Sky, what would the cube root of 64 be? All right. Now, this might be the most important thing I teach you, possibly from this entire chapter, and I'm including Pythagorean theorem. This is the one mistake I see made more than any other. Do parentheses matter? Well, let's find out. In your calculator, I want you to type in negative 2 squared. Everybody try it. What do you get? What's it say, Xander? Negative 4. Wait a second. We just said that when you square a number, it always results in a positive number. What just happened? Well, here's what happened. Your calculator did not make a mistake. When you do negative 2 squared, according to order of operations, exponents applies first, And so the exponent is going to square the 2. Then after exponents comes multiplication and division. And so that negative sign, it's actually the same as a -1. So what your calculator reads, when you type this into your calculator, this is what it sees. Your calculator's not dumb. That's actually the answer to that problem. Now, try it again, but put the -2 in parentheses, which means you got to hit your parentheses, -2, close the parentheses to the second power. What do you get? Sky? This time it's 4. The parentheses absolutely matter. If I'm squaring a number and it's negative, if I have a negative base, you guys remember exponents? You have the base and then you have the exponent. The whole thing's called a power, right? If I've got a negative base, I have to write it in parentheses. Otherwise, the negative isn't part of the base. And therefore, my answer is not going to be what I'm expecting. Now, watch what happens when you do it with cubes. -2 to the third power. Type it in without parentheses. What do you get? Sky? -8. Sky's already tried it. Okay. Who's done the second part here? Person? You haven't tried it. Well, yeah, no, you said 8. So if you're saying -8, that is correct. It should be -8. Oh, you're saying also the same as before. Gotcha.
So I typed it in wrong. That's why I got it wrong.
Well, yeah, I knew that. I just, when you said also 8 or also -8, it made me think I heard you miscorrect it the first time. So it's not that parentheses don't matter with cubes. These -8s are both negative for 2 different reasons. When you type in -2 to the third power with no parentheses, this is what the calculator sees. When you type in -2 in parentheses to the third power, this is what the calculator sees. Not the same thing, but the same answer. It happens to be that when you do negative times negative times negative, you get a -8. And if you do 2 to the third power times -1, it's still -8. So the parentheses, I guess, aren't as important when you're cubing a number, but when you're squaring it or raising it to the 4th, 6th, 8th, 10th, 12th, 14th powers, any even power, the parentheses are extremely important. Okay, because that's going to affect whether it's a positive or negative answer. But for a cube root or a cube, it's not going to matter as much. So the negative is only repeated when it's inside the parentheses. I like to think of it as exponents are nearsighted. Anyone in here nearsighted? Okay, what does that mean? You can only see things when they are close. So to help, we have the parentheses, right? The parentheses act as a pair of glasses or magnifying glass. If the parentheses are there, the exponent will see the negative and therefore it will repeat it that many times. If the parentheses are not there, the exponent never sees the negative and the negative doesn't get repeated. And here's what happens if the negative doesn't get repeated. It's still there. There's just 1. So the answer is going to be negative always. Okay. Sometimes that doesn't matter. Sometimes it really does. So if your base is negative, you got to write it in parentheses. That means when you take your quiz Friday, if your base is negative and you don't write it in parentheses, it will be counted wrong because the answer I would get if I did what you wrote would not be correct. So put negative bases in parentheses. They are nearsighted. They need the help. Determine whether the square or cube is a positive or negative number. If I square, I'm not asking you to use a calculator right now. If I square -1 and -1's in parentheses, will I get a positive or negative? Shout it out. Positive is correct. Yeah, it sees the negative, it repeats it twice. This one's in parentheses. Does the exponent see it? Is the exponent going to see this negative? Yes, it will. How many times will it repeat it? 3 times, and the answer will be Negative. So just because it sees it doesn't mean it's going to be positive. It can still see it, and for a different reason, because there's 3 of them now, it would still be negative. Does the exponent see this negative? No. So it's going to get 16, and then because it never even saw the negative, it's going to make it negative 16. It's not in parentheses. Does the exponent see this negative? Still no. Is it going to repeat it? Not if it doesn't see it. But if it doesn't repeat it, how many negatives are there then? If it doesn't repeat it, how many negatives are there? Still 1. And so it's still going to be negative. All right. So when you are cubing a negative number, it doesn't matter if you use, I mean, it kind of does matter, but you get the same answer. The calculator sees 2 different things, but you get the same answer. But if you don't use parentheses when you're squaring or raising something to an even power, it will throw your answer off because it will give you a negative instead of a positive. All right, order of operations time. So we said yesterday that square roots actually happen during the exponent step. Cube roots are the same thing. Cube rooting a number is raising it to the 1/3 power. Okay? Cube rooting is raising it to the 1/3 power. I don't think I mentioned this yesterday. What if I wanted to raise, whoa, I should erase this. What if I wanted to raise something to the 2/3 power? How would I even write that? Martin? That's exactly right. It would look like this. Nice job, Martin. Whatever number is on top of your fraction, that 2, goes inside the square root symbol. Whatever number is on the bottom of your fraction goes outside the square root symbol. Now you might be thinking, why didn't we write any of that yesterday? Because when we rose our squares to the 1/2 power, putting a 1 inside isn't going to do anything. Timesing something by itself, no, sorry, not timesing by itself, you're timesing, it's just one of them. You're not timesing by anything. So it doesn't actually do anything. But if you have a numerator other than 1, you would have to write it like this. So those are actually the same thing. And that is not at all going to be on your test. So let's skip right to this. Just an interesting fact. I need to do the cube root of negative 216. Jace, can you tell me what the cube root of negative 216 is? Okay. You have a calculator like me?
Yeah.
3, second function, exponent arrow, negative 216. Negative 6. Got it. Okay. What do I do next? Do I times by 2 or do I subtract 3, Oliver? Okay. What's 2 times negative 6? Okay.
Calculator. It was by accident, I promise you.
Thank you, Navion, for returning it. Yes. Negative 12 minus 3 is the same as negative 12 plus negative 3. What do you get for negative 12 minus 3? Person? Negative 15. All right. What happens if I'm cubing a cube root? What's going to happen, Maddox? Yeah, absolutely nothing's going to happen. If I'm cubing a cube root and they're inverses, then it all cancels out. And I'm just left with negative 15 minus 21. Maddox, what's negative 15 minus 21? Negative 36. Yep. Same as negative 15 plus negative 21. Same sign, keep the sign. Add. Example C. The cube root of 8 is the first thing I would do. Oh, and what's the cube root of 8? Or what times what times what gives you 8? 2. Got it. Okay. Lucy, 4 times 2. Okay. Martin, 18 minus 8. Yep. Simple order of operations once I get the cube roots out of the way. Example D. Now, this is a really, really long root symbol. It doesn't have parentheses, but I want you to kind of assume that they're there. I mean, what are you going to cube root if you're not sure what it is, right? So we got to actually do the addition here first before we cube root. So you're going to put your own set of parentheses there and kind of make sure you do what's under the cube root symbol first so you know what you're cube rooting. What is negative 555 plus 43? Jacoby. Okay. Negative 512. Didn't we say that's what 8 cubed was? 8 cubed is 512? Is that right? Or is it 8? It's 6 times, no, it's not 6, is it? It's 8, okay. So that's gonna give us not 8, but this time it's actually negative 8 because it's a negative under the cube root symbol. Hold on a second, let me get rid of that. Let me make sure I put a 3 right there. So we have negative 5 times negative 8. Chloe, what's negative 5 times negative 8? 40. All right, find the side length of each cube. Has a volume of 0.001 cubic centimeters. Cube root that. Sky? 0.1. 0.1 times 0.1 times 0.1. 1 times 1 times 1 is 1, but the 1 decimal place times the other decimal place times the other decimal place means I need 3 decimal places. So 0.001 is the volume. What about if the volume is 1/8 and I got to cube root that? That's really cube rooting the top number and then cube rooting the bottom number, Lizzie. 0.5. You could also say a half, and a half, or 0.5. You're right. That would just be a yard for that one. Next example, write the prime factorization of 216. Do you remember doing prime factorization, factor trees? It says write the prime factorization of 216 and then use it to find the cube root of the number. Well, let's see what the prime factorization of 216 is. Can you give me any number other than 1 that goes into 216? Maddox? 6 times what? 6 times 36 gives you 216. Okay. Now, remember, I keep going until they're prime. 6 is not prime. 36 is not prime. So let's break down 6 into what? Shane? 3 and 2. That's prime. That's prime. Let's break down 36 into, Sky? 6 and 6. And we know that that's going to break down to 3 and 2 and 3 and 2. It says use it to find the cube root of the number. Well, how would I know what that is? Well, if I write the prime factorization out using exponents, I would get 2 to the 3rd power, hang on, times 3 to the 3rd power, which is the same thing as 2 times 3, 6 to the 3rd power. Double check that. What's 6 cubed? 216, isn't it? So the answer of this is not 6 cubed. The answer is actually 6. 6 is the cube root of 216, but you can use the prime factorization. It happens to be on this one, but they're both raised to the 3rd power. We'll finish up our notes tomorrow, and then I will see you guys later. Enjoy your evening. Remember that section 7.1 is due to. All right, find the surface area of the baseball display case if the volume is 125 cubic inches. I believe there's a question like this in your 7.3 homework where it asks you from volume to surface area. Julie, I see you nodding. Did you get to this one? Did you know how to do it? Can you describe how you would go from volume to surface area here?
So what I did was I knew that like the surface area would be just
Thank you.
the area one of the sides to the 6th power.
Oh,
Wait, no, not the 6th power. Times 6.
okay, yes. All right. So if you didn't hear that on the video, what she's saying is cube root 125, because that's going to give you the side length of a cube. This does not work if it's a rectangular prism. Well, this is a rectangular prism. It only works for the cube, right? For the special type of rectangular prism, because for a rectangular prism, the length, width, and height could be 3 different numbers. But for a cube, they're the same. So Julia, what did you get for the cube root of 125? Okay, so all the side lengths of the cube, this display case, they're all 5 inches. All right, so once you said that each side was 5 inches long, go from there again.
You have to find the area of one of the sides. Multiply that by 6.
All right, she says find the area of one of the sides. Julia, what's 5 times 5?
25.
Okay, or 5 squares 25, and then times that by 6 because there are 6 of those 25s. And what does that give you, Julia, for the surface area?
150 inches.
Good job. Yeah. Yeah. We go from volume, which uses cubic units, to surface area, which uses square units because of the area. So find the side length of your cube. Use that to find the area of one of the sides of your cube, and then times that by 6 equal sides. Yep. So the volume is 125 cubic inches, and the surface area is 150 square inches. Good job. And so she used this formula here. That's how she knew to cube root. And then she said surface area of a cube is just area of one of the sides times 6. All right. So now that we've talked about square roots, squares, and cube roots and cubes, let's answer some of these questions by completing each statement with positive or negative. A positive number times a positive number is a blank number. Dawson, it's a positive number. A positive times a positive is a positive number. How about a negative number times a negative number, Sky? Positive. That right there explains why you can never have a negative number under your square root symbol. Because every time you square a number, it's either going to be a positive times a positive, or a negative times a negative, or 0 times 0, right? But it's never going to be negative. So that's why you can't have a negative in your square root symbol. Are you allowed to have a negative in your cube root symbol? Yes. Okay, so let's keep going. A positive number multiplied by itself twice. So positive times positive times positive is positive. A negative number multiplied by itself twice. So negative times negative times negative. A negative number multiplied by itself twice. So you have a negative number and you're multiplying by itself once and twice again. So it would be negative. There you go. And that is why you can have negative symbols in your cube roots, because -2 times -2 times -2, or -2 cubed, is -8. So you can have a negative when you cube a number, but not when you square a number. What if I had a negative number to the 6th power? Is it going to be positive or negative? A negative number to the 6th power. Alex? A negative number to the 6th power. Well, you're guessing correctly. Because if you raise something to the 6th power, doesn't it repeat 6 times? And if you have 6 negatives, wouldn't they all pair up? What about a negative number to the 10th power? Positive or negative, Xander? Positive. A negative number to the 13th power. Carson? Negative. A positive number to the 13th power. A positive number to the 13th power. Yeah, a positive number to any power is going to be positive, right?
Negative power to an even power is always going to be positive, right?
Yep.
And then to the odd number, it's always going to be just like it can't do its self out.
Except for 1. Yep. For the odd. So yep, what she just said was a negative number to an even, raised to an even power is always going to be positive, and a negative number to an odd power is always going to be negative. That's exactly right. But a positive number to any power is still going to be positive because there's no negatives. All right, there's our lesson for section 7.3.